All right, over to you, Anthony.
All right. I should have the PowerPoint main page here. You got that.
I can see your screen.
Now, do you see the slide, the main slide?
Yes.
All right. And feel free, if I can get somebody to watch the chat for me right now, my chat window's hidden.
I would be moderating that, and I'll let you know.
Okay. And it's Tony. These companies insist on putting me in under my legal name, but normally the only people who call me Anthony are when I'm in trouble.
I'm sorry, you are not in trouble, Tony.
So tonight we're going to talk a little bit about how to get access to Azure, how to build application access. And I'm going to start by backing up and talking a little bit about the front getting in, a little bit about the OSI network model, and then we'll talk about some of the specific tools and maybe couple third-party tools. About me, I'm part of Sogeti. I've been in Sogeti for almost a year. I think I've got a couple more days to go before I hit my anniversary. I've got a few certifications up there. That's my CISSP is the one I'm probably the most proud of, because that one it's a certified information systems security professional, and that one takes quite a bit of work. Most recently, I added the Azure Solutions Architect. I have my AWS. I'm part of a couple of cool organizations up here in Minneapolis, where I'm part of. We have Toastmasters, and anybody who, if you're going to do speaking for events like this, I'd highly recommend getting involved with a Toastmasters chapter. And then I'm a part of on the board of our local Association of Enterprise Architects. I want to address the importance of a good architecture. This is a meme that's been going around the internet for a bit, and periodically it pops up on LinkedIn, on the cybersecurity hub. And this is when your security gate turns out to be a ladder. If we don't build our architecture properly, we wind up with something like this. This gate looks like it's fantastic. It's got a really good key lock, nice doorbell and everything. But a determined person could actually use that as a ladder and climb in and over. So we really want to think about the architecture that we used and make sure that it fulfills the purpose. I'm touching a little bit on security. So one of the things that we want to do when we're building our Azure architecture and how we build access to our application is keep in mind what in the information security world is called the CIA triad. There's three key components to information security and keeping your site secure. You want to care about confidentiality. Make sure nobody the people only see what they're supposed to see. Integrity. You don't want anybody changing things they shouldn't change. Availability. Making sure it stays up. Do I keep it? Do I use one region? Do I use multiple regions? That can figure into the availability. If we're building up things like our storage groups, am I using the multi-zone? Am I using GRS, LRS, the locally redundant, the region, the geo redundant, the zone redundant? All of those help determine our availability. And those are the things that we want to build into our site. Since we're going to be talking a little bit about load balancing and routing, I thought it's not a bad idea to review the OSI networking model. I assume that everybody's probably seen this at some point. You start out at your lowest level. That's probably your wires and your radio waves. Then at the data link level, how do you send packets over that wire? Typically things like Ethernet. Your network layer, that's the broader internet. And that runs the IP protocol mostly, and then there's a few other control protocols used for routing and things. TCP and UDP are the key protocols, and this is one of the places where Azure will add load balancing. And we'll come back and we'll look in depth at the layer 4 load balancers shortly. Now we've got our upper layers, which are all managed to control the application. At the highest, basically you have HTTP and HTTPS. And those are layer 7, and those are the layer 7 routers. And then we've got a couple adjunct things that Azure allows us to do. We can use traffic managers, and DNS is another way to do some routing. So what is layer 4 routing? At layer 4, the entire request is pretty opaque to the router. The router can't see in, and if you've looked at if you've ever looked at how HTTP works, you've got the information used to send it across the wire, but it can only see that this is a TCP message, pretty much that it's just TCP or UDP or something like that. And it can't really look inside. It can't see things like the rest of the path within the URL. So I might have something like my http://mycompany.com/my-local-path. Well, the my local path is invisible when routing at layer 4. All of the extra headers that control things like authorization, you can't see that. Your back-end service is what has to handle things like authentication and HTTP, encoding and decoding HTTPS. Layer 4 is great to use for a simple site, especially where you only have a fairly uniform backend. You might have more than one instance. I'm going to have an app service and have 5 instances of it, or multiple, or 3 VMs or something like that, but they all present a uniform service. You don't need to care, your routing doesn't care as much. You're not as concerned about security at the network level. Instead, your security, you're going to let the back end handle that. And you're going to have to, when you take your SSL certificates that you use for HTTPS, you'll want them installed on all of your back end servers. And but because your layer 4 has nothing to do with that. So that brings us to Azure Load Balancer. Azure Load Balancer is a layer 4 load balancer. And you can use it either internally or externally. And this is what a typical external load balancing might look like. You're going to build your network. You probably want to you're going to create a virtual network for your main region, or for your only region in this case. You're going to use a load balancer, and you'll put that in your front end subnet. And you probably want to put your service, and it will typically route to either a Windows VM, a Linux VM, a scale set, an app service. You could put an AKS cluster behind it, but if you use AKS, you're going to have to install things inside of AKS to do all of the ingress handling, because the load balancer can't help you. Sometimes you want to make that load balancer run in multiple regions, or you want your site to run, maybe I want to run in the East region and the West region, or maybe you have a multinational and you want to put something in Europe, someplace in the Pacific, and so you'll have multiple regions. That's when you might want to add to this simple layer 4 routing, you want to add a traffic manager. And basically, this is a nice picture that Microsoft puts out that shows how your traffic manager works. I'm a user sitting at my browser. I put the URL and path of your application that you built. They'll put that in. And the first thing it does is it tries to resolve the host name. And all the traffic manager does is resolve that host name and say, based on the current rules that were defined when I was set up, I'm going to give the user the IP address of this region or that region. You can, when you're configuring your traffic manager, you can give priority to one region over another. You might maybe you want the North Central region to bear most of your traffic. In fact, almost all of it, unless the North Central region goes down for some reason, and that's why we do multi-region builds. In that case, the priority will say, okay, I'll switch it to maybe South US or West US or some other region. You can set it up to be region. You can give priority. You can give weighted access. You can do simple round robin. You can give everything the same priority. You can say performance. I want the fastest possible connection for my users. So I want you to use traffic manager, route it based on performance. Whatever's going to serve them the fastest, give them that IP address. And finally, you can use Geo Routing, where I say, this is a US, if they're in the US, you go to here. If they're in Europe, go to this other region. Here's an example of how you might build out your network. And in this case, I've just sort of coalesced the backend service to be whatever you're using that's in your backend. The front end subnet, and then you put your traffic manager, sits out completely outside. It's effectively outside of Azure as far as we're concerned. It's outside of our network setup for sure. And it'll pick which region should I send these requests to? Well, next we get into layer 7 routing. A layer 7 router can have full visibility into your web requests. Of course, to do that, you have to take the certificate, your site certificate, and instead of installing it on all of your back-end servers, you install it on the router itself. That allows the router to handle all of the SSL encoding. In fact, you can put rules in there to say, if somebody comes in on port 80 and wants to talk just HTTP, send back a message telling their browser, no, switch to HTTPS and come in on 445, or on our normal SSL port. You can also put some authentication handling in the router because it can see into the packet. It can look and say, do they have an authorization token? The router can also use, a layer 7 router can also look at the part of the URL that's after the host name. So you might route your images over to this location. Let's say you might want to put your storage account to serve up images and media and things, while your main application sits on a different part of the path. The other thing that you can add to many layer 7 routers is what's called a web application firewall. We'll talk a little bit more about that shortly. Layer 7 routers are, let's say you have complex sites. I want to have service A on one set of machines. I want to have service B with a slightly different path on a different set of machines. Maybe I have my API on a third set of machines. Or even have a API management service sitting in there. There's all kinds of complexity that you can put in there. And I'm going to put storage accounts behind for my media, like my images and video and audio files. A web application firewall. We all should be very worried about all the ways that the AB users will try to use our site. We want our users to have free access, but not the people who want to do nasty things. So a web application firewall, as you can see from the slide, will help protect from some of the common things. And typically, a lot of the things that it will protect from are things that fall into the OWASP top 10. And this is from the OWASP organization that just shows a few of the different kinds of attacks that people use. And you look at things that are up here, injection. And if you were to go back and look at the top 10 going back many years, injection attacks where somebody takes and tries to put code into that fill in the blank, or try to use cross-site scripting, A lot of that stuff's been around a long time, and we don't seem to be getting better at keeping our sites very secure from these kind of things. So using a web application firewall, or using that WAF service as part of our layer 7 routing can help mitigate some of these concerns. So Azure provides natively the Azure Application Gateway. An app gateway lets you put out a public IP, and then you can optionally through a particular SKU say, I want to use the web application firewall with it. And you can then configure multiple backends. You can install your certificate here. And this is a great way to give access to your services, the services and applications that you're building for your customers. Here's the simple way that you might set it up. You have your application gateway sitting in your front end subnet, and you have your backend services, storage accounts, and you could have multiple different backends. You could even host multiple websites. So, I've listed here a few of the things that web application or that an app gateway is good at. It's very good at handling high traffic. It can route on multiple criterias. You can let it take care of most of your SSL. You can configure it to do ingress for your AKS or Kubernetes cluster. App gateways also support WebSockets. You're building one of those highly interactive sites where you want to build a chat application or some other application where there's lots and lots of back and forth. App gateways and WebSockets are great for that. So we've got our you can put multiple back-end applications, multiple websites. And you can always put a traffic manager, and you can also replicate your setup in multiple regions, and of course, use a traffic manager with that. Sometimes you might want to if you're going to do a lot of multi-region stuff and you want to improve your performance, you might want to sometimes we want to consider doing something like what's called a content delivery network, or CDN. Microsoft's been pretty powerful lately and doing some cool things with it. And we now they've added a new service. Well, the Azure FrontDoor has been around for a while, but recently they've done some really nice upgrades so that you can integrate things like a web application firewall with it. So your setup might look like this. And in this case, instead of having to have multiple app gateways, you can in many ways, FrontDoor is like a multi-region app gateway with content caching. I have images, they get loaded up. In addition to that, instead of having one or two limited ingress points into the backend network, FrontDoor adds in the capability of dozens of local ingress points. This is one of the CDN capabilities. This is your CDN on steroids, which supports not just static content delivery, but application delivery. So if you're building if you really want to build a multi-region network and you want everything running concurrently, this might be a great application for that. There are also some third-party tools, and I'm just going to cover a couple. And you can put your third-party tools inside or outside of Azure. One of the ones that the client that I'm at right now, they have a number of on-premises sites that were built around Nginx. Nginx is effectively, well, it's a little bit more than just an app gateway. It's a full-on web server that can act as a app gateway. There's standard images, there's standard library images that you can use in Azure. Now, a couple of things to keep in mind: that when you deploy Nginx, you have to set up a VM using one of the standard images and then deploy your rule sets there. So it's a little bit more complicated, but it's almost like an appliance. And if you use something like a VM scale set, that can work really good. One more application, and I'm just showing one, and I think there are a few others. I think AKAMA is another one that does something very similar to Cloudflare. Cloudflare is its own front-end network that's completely external to Azure. Cloudflare is really, you can put layer 7 web application firewall and routing. It's got a few capabilities in it that you can actually do a little bit of coding. JSON, it actually uses JavaScript. It's got a JavaScript engine that can look at the request and do things with the request and do some routing and rewiring and same kind of things that your app gateway can. Why would you want to use an external service? Well, because it's so distributed. Things like Cloudflare provide very good DDoS protection. And I'm assuming that everybody's familiar with DDoS, or distributed denial of service. And those are things that we want to consider when we're building our networks or our applications. What are some other considerations? One of the words that you've hopefully heard a few times is the concept of zero trust. Back in the good old days, when the internet was brand new, you typically would build, I'm going to put a firewall here between this and the internet, and I'm going to create this thing where my main web servers sit. And then I'm going to put another firewall behind that. And between the two firewalls, we'll call that our DMZ, or demilitarized zone, where it's semi-trusted. But I put my database servers and things like that behind a second firewall. But once I get behind that second firewall, I trust everything. That's a bad idea. We've learned that that kind of trust is not something we really want. It's better to do zero trust. Use HTTPS on all of your connections, even inside of your VNets. So when server A calls server B, when you do those what are called east-west connections that are within your network, it's not a bad idea to protect those connections with TLS or HTTPS connections. And not only that, put certificates on both servers so that when I connect to the target server's got a certificate, and I can say, yeah, I know that I'm connected to target. And then the target says, well, client, tell me who you are and give me your certificate so that I have assurance that you're client. You're my safe client. So we want to use HTTPS. You may even, the other thing, you also want to put HTTPS between, well, especially when you're building an app gateway, when you're using app gateways on layer 7, you want to use HTTPS from on what are called your north-south, or those are the ones that go between layers and out to the internet. We want to secure those connections too. I want my app service that's sitting in Azure to only talk to certain IPs. For example, my app gateways. I don't want people to be able to come, and Azure is very nice. So when I create an app service, typically a lot of Azure's services, my SQL Server, my app service, all of my other services, a lot of those have public addresses and are by default publicly accessible. Well, we want to secure those connections. People shouldn't be able to say, oh, I'm going to skip going to your app gateway. I'm going to just sort of sneak around the side and go direct to the app service. Sometimes we do things like that for testing. We say, well, I want to make QA's life easier, so I'm going to just allow people to go around. Well, by using things like mutual certificate authentication and IP restrictions, we can help protect our service and say, I want to make sure it's coming through a channel that I know is secure. Don't let any insecure channels in. Now, if you're using mutual certificate authentication and your app service has a public endpoint, you could give your QA team its own certificate to use for that mutual authentication, and that would be one of those allowed authentications, but only at specific times. Like, you don't want it all the time, only when you're doing a deployment and have to do that testing. So I'm going to come here and sort of summarize that we have many ways to secure our entry and to provide entry into our back end. There's a lot of other ways that you can get into your app services, but generally we want to consider putting one of these mechanisms in front of it to help keep it secure and help keep it highly available. We want to ensure that integrity We want to ensure that availability. We can think about, when is DNS enough? For example, if I'm handling everything on my app service, I'm using an Azure app service or an Azure VM, and I'm handling all the security and incoming connections appropriately there, I could just use Traffic Manager and DNS routing. And if I only have a single instance of my VM, that's probably great. Once I start having multiple instances, then I probably want to consider putting a load balancer in. When it gets a little bit more complex and needs a little bit more secure, a little bit more security, and a little bit more protection, maybe we want to step up and look at layer 7 routing. Layer 7 routing also has the advantage of, if I install my primary network certificate or my main host certificate on my gateway, I have fewer places that I have to install it, and there's less chance of somebody getting in. I get into the VM and I steal your star.mycompany.com certificate. There's one less place. There's the less places I've got it distributed, the harder it is to steal. And sometimes we want to look at CDNs when I'm doing multiple regions. And there are good cases for using Azure's internal or native services, and sometimes you need the third-party apps work really good. If I'm ever dealing with multi-cloud, I might want to use something like Cloudflare. Or maybe I'm going to put my Nginx server on in my AWS network and in my Azure network. And I can put similar rules on both of them and configure them very similar. And so it provides a little bit more multi-cloud support. One of the favorite answers that any architect is going to ask is going to say, well, which of these should I use? Well, it depends. That's your typical architect's answer. It depends. What's your use case? What's your budget? What's the cost versus the benefit of each approach? If I'm running a very simple, tiny website where, especially serving static images, well, I might not need the web application firewall support. I might not need that layer 7 support. Now, in general, we should avoid any site that doesn't. If you look at things with Chrome and Edge and Safari and just about every browser out there these days tend to, if you try to go to a site that isn't SSL enabled, it's going to say, do you really want to go there? I'm sure if you've gone to something where you just put http/something and it doesn't come back and tell you to go to HTTPS, you've probably seen the pop-up in the browser saying, are you sure about this? But security and availability get more costly. It's cheaper to just use a traffic manager or a layer 4 load balancer. An Azure load balancer It can be pretty good if you can distribute your security onto all of your backend services. That could be great. And it's going to be a little less costly than using a layer 7 app gateway. Things like Nginx cost a little bit extra. Cloudflare or AKAMA or other similar services have their own cost, and it's built separately. Nginx with Azure, since it's an image that's built into like many of your standard services, that billing is built in. So which should you use? Well, what do you really need? How important is confidentiality on your site? How important is integrity? If it's the more static it is, well, the less you need to be concerned about things like SQL attacks, injection attacks, or cross-site scripting. What's the benefit of each? If you're running a banking application, you better be using app gateways or FrontDoor. If you're running a simple blog site, a simple load balancer might suffice. Or maybe even in that case, you don't even need to go to the load balancer, because unless your blog's really, really popular, you probably don't. You might not even need the load balancer. But these are just a few of the options that we have, and a few thoughts that we can use and think about. So that's probably the core of the presentation. And I did want to take a couple moments to just do a shameless plug, and then I'll make the slides available here, but there's a couple upcoming events that people could be aware of. The AEA that I'm part of, we've got an event coming up in about 2-3 weeks now. It's talking about microservices and event-driven architecture. Then we also have this year the Midwest Architecture or MAC group has put on a conference for the past several years on architecture, and Thursday, November 4th. I'll make the deck available, and if anybody's interested, click on the links and give it a visit. I'm going to end the slideshow at this point, and if anybody has questions.
Awesome. Thanks, Tony. I don't see anything on the chat window, but I did posted the link to the decision tree that Microsoft has published to choose a load balancing solution in Azure. So I hope it will be helpful as well. And if you can share the slide deck with me, I'll go ahead and publish it along with the YouTube channel. So if anyone has any question, or if you would like to discuss or ask anything to Tony, please unmute yourself and you can ask him now. I guess not. With that, on behalf of the user group, I would like to thank you, Tony, for taking your time today to present on in the user group today. The topic was great, and I'll go ahead and stop the recording now.
All right.